There we go. We're ready for another video with a circuit working in AC. So, the circuit this time is the following one. I'm gonna have a resistor, inductor, and then an impedance here, U, and then something like, well, this is gonna be my EA. And here at the bottom everything is going to be connected, and this one is going to be my EP. I'm going to define this current as I. This is my R, this is my X, and the problem is saying that for the circuit on the left working in AC, we know that EA is 220 plus I 0 volt, effective value. R is 1 ohm, X is 1 ohm, VPU is 2 kilowatts, cos phi is 0.95, find the cost of the active energy for the user WU, the line W1, and the generator WP. We assume that 1 kilowatt hour costs $0.12. Can I make the dollar symbol? Yeah, there we go. I generally write euros or pounds. I don't write dollars. It's weird. Anyway, yeah, dollar. And that the circuit works for 24 hours a day for 60 days. Okay, so 4 minutes only to write what the problem was saying and and the circuit itself. So first thing first, let me get PU. So PU will be EA times I times cos phi U. So I is actually PU over EA times cos phi U. which is what we're interested in, I. So we can find I. Therefore, I, since we know all those things, is just 2000 over 220 times 0.95. So I is 2000 over 209. So I 2000 over 209 is 9.54 amps. So we have found I, our current. Now that we have the current, we can say, okay, EA is actually on the real axis. So I complex would actually be I times 0.95 minus I sine of arc cosine of 0.95. Therefore, I is a complex is 9.57 times 0.95 minus I sine of 0.317. So I complex is 9.57 times 0.95 minus I 0.31. So I complex is 9.09 minus 2.96 I ampere. Now I can find, now what I'm gonna find is the starting voltage EP. So the starting voltage EP will be EA plus ZI times I. Oh, I complex, of course. So EP will be 220 plus 0I plus 1 plus I times 9.09 minus 2.96 I. So EP will be, well, what do we have here? We have a product of two complex numbers. So these will be like A plus BI times Z plus DI, which will give me AC minus BD plus AD plus C plus, I'm sorry, BC. Yeah. So EP is, well, I'm leaving this one around, multiplying those two. So 220 plus 0I plus 1 times 9.09 minus 1 times negative 2.96 plus 1 times negative 2.96 plus 1 times 9.09 I, of course. The last term is with I. So EP will be 220 plus 0I plus 9.09 plus 2.96 plus negative 2.96 plus 9.09 I. So EP is 220 plus 0I plus 12.05 plus 6.13 I. So EP is 220 plus 12.05 plus 0I plus 6.13 I. Therefore, EP, I'm getting there. It is 200.32.05 plus 6.13 I volt. So yeah, I found EP. Now I'm gonna find the operant power, the complex operant power, the starting complex operant power. So the starting complex operant power, which I'm gonna call AP complex, will be EP times I conjugate. So AP is 232.05 plus 6.13 I times 9.09 minus 2.96 I. So this is once again a product of two complex numbers. So this will be like saying is A plus BI times C plus DI, which will give me AC minus BD plus AD plus BC I, of course. So AP will be 232.05 times 9.09 minus 6.13 times negative 2.96 plus, and now the terms with the I, those guys here, 232 point plus blah 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 232.05, which is this one times this one, so times negative 2.96 plus 6.13 times 9.09 I. So let's find what it is. AP is 210. Well, no. Is those two multiplies is 2109.33 plus 18.14 plus these one. So negative 686.87 plus 55.72 I. So my AP is 2127.47 minus 631.15 IVA. And it's not over. It's not over because, well, but then, since I found AP, then I know that AP is equal to PP plus IQP, which is this value here is 2127.47 minus 631.15 IVA. But since I know this, I can find the, well, I know this, but now I do know this, but I still gotta find the active power dissipated on the line. So the active power dissipated on the line, which I'm gonna call PI, is going to be R times I squared, because the Ohm's law still applies. So this is Third Ohm's law, R times I squared. Doesn't matter whether we are in with complex things and so on, with AC and so on. Ohm's law still applies, as I said. So PI, the power, the active power dissipated on the line is I times R. So PI is 1 times 9.57 squared. So PI is just 1 times 91.6, which is, well, it's just 91.6. So 91.6 watts, of course, since it's the power. Now, the balance of the active powers, the balance of the active powers will be PA equal to PU plus PI. So basically PA is 2000 plus 91.6. So PA is 2091.6 watts. But we know that PA is equal to PP. So we can verify this, and we will get that PA, which is 2091.6, is equal to 2027.47 watts. Well, it is. I'm just gonna add this. It is. It is verified. I've just rounded a few numbers, so we can just say that the balance is actually verified, and those two are equal. This is what happens when I use my calculator to round up those values. But anyway, I can just say that I'm gonna consider this as if those two are equal. Anyway, it's not over but it's almost over. It's almost over, but it's not over, because now, well, let me just now I verify the balance of the optic power, but I still have to find the cost of this for 24 hours and 60 days. So for 24 hours and 60 days, 24 hours and 60 days. So I'm gonna find the energy. Well, with T equal to 24 hours and 60 days. So WP will be PP times T, which is 24 hours and 60 days. So WP will be what was P? PP. We had that, and for the user, the active line, the generator. Okay, so whoops. So we basically have that WP is 2.127 times 24 times 60, which is gonna give me a WP of 3062.88 kilowatt hour, and WI is PI times T. So basically WI will be 0.00916 times 24 times 60. So WI will actually be 131.90 kilowatts hour, and WU will be PU times T. So WU will be 2 times 24 times 60. It's gonna be pretty large. WU is 2880 kilowatts hour. Now, to find the cost, I can say that the cost of P is WP, which I just found, times the cost, which was $0.12. So if I multiply it by the cost, I get 3062.88 times 0.12, which is $367.54 to run this appliance for for that time, so for 24 hours a day for 60 days. And the cost of I is WI times 0.12, which is 131, oh no, 131.90 times 0.12, which is $15.82. And the cost of U is WU times 0.12, which is 2,880 times 0.12, which is $345.6. Yeah, so that's pretty much it.